How do electric trains work? A journey from Mumbai to New Delhi. A train is a form of transport consisting of a series of connected vehicles that generally runs along a railroad track to transport cargo or passengers. It represented a turning point in history that changed the world forever. Without trains and railroads, the world would be an altogether different place. These marvelous machines structured the social, physical, and economic foundations of many nations. Cities began to organize around newly constructed stations that became icons in themselves, like some sort of sanctuaries representing the pleasures of travel. In this video, we will explain the working principle of electric trains through the travel made by the JAES CEO who will leave the city of Mumbai to reach New Delhi. With over 200 years of innovation and improvement, the train industry managed to grow from its simple steam trains through diesel trains, electric trains, up to modern high-speed trains and maglev trains. The first Indian electric train made was introduced on February 3rd in 1925, right at the Mumbai station. Indian Railways is the fourth largest railway network in the world by size. With a route length of 41,861 miles, it carries over 23 million passengers every day. The JAES CEO is at the central station of Mumbai. The Chhatrapati Shivaji Terminus is one of the most iconic terminal train stations and is a UNESCO World Heritage Site. Here the CEO gets on a train with electric locomotion. Electric trains, unlike steam trains or diesel trains, do not carry fuel or water on board. But instead, they use electrical power as one of the most reliable sources of propulsion. A catenary system, in fact, is used to transmit electricity to the train. This electricity is produced hundreds of miles away from the railway, and it is carried to the overhead line thanks to transformers. You can watch the video about the working principles of transformers by clicking the link at the top of the right corner of this video. The electricity flowing through the overhead line is an alternating current, and it usually has a voltage of 25 kilovolts. When the train is ready to go, the pantographs, which are placed on the roof of the locomotive, are pushed up with the help of air pressure. The head is the only part of the pantograph to touch the wire pickup. The current is collected via metallized carbon strips on the head. Plus, the zigzag configuration of the overhead contact wire ensures a symmetrical wear of the head surface. The voltage collected from the overhead wire passing through the transformer completes the circuit on the rails, using brushes on the axis of the wheels. Transformers and rectifiers inside the locomotive are used to modify the parameters of the electrical power taken from the overhead line, so that the onboard inverters can generate a three-phase alternating current in order to transfer the power to the wheels and obtain the right traction power to move the train. Furthermore, the auxiliary inverters supply the necessary current to power the onboard equipment and instruments like cooling fans, necessary for lowering the temperature of transformers and motors, accumulators, which need to be constantly charged in order to sustain the startup phase and power the basic electronic systems even in the absence of a power supply. Compressors, which are very important devices useful to provide compressed air. Compressed air is an essential element that powers many of the most vital functions of a train. Without compressed air, in fact, a train would be unable to raise or lower its pantographs, open and close its doors properly, or even engage the sandbox. which is a container filled with sand, usually placed in front of the driving wheels of the locomotive in order to drop the sand on the rail in wet and slippery conditions and on steep grades to improve traction. Even the brakes operate through air pressure. Basically, the train brakes are always on. For this reason, a brake pipe delivers pressure to the brakes, putting them in the running position and letting the train move. On the contrary, if the brake pipe stops delivering pressure, the brakes will be in the release position and the train will simply stop. Each wagon is provided with a brake. All the brakes work simultaneously. In this way, if there were any leaks in the compressed air system, the brakes, not having the required pressure, will simply stop the train, preventing accidents. The extensive network of Indian railways passes through dense forests, which represent a natural habitat for many species of wild animals in India. But the rise of the speed of the trains and the consequent risk of train accidents is putting these beautiful areas in danger. India has been involved in train accident prevention programs for many years now, with the aim of protecting the wildlife of these natural reserves, which are considered national treasures. The bogie of the train is a chassis or framework that carries the running gear, the supporting structure connected to it, and the traction motors, usually three-phase AC motors. You can watch the video about the working principle of three-phase motors by clicking the link at the top right corner of this video. In an electric train, the engines are located in the bogies of the locomotive. A locomotive can have many bogies, and so it can be more or less powerful. Each train car is equipped with 2 bogies. This allows a quick disconnection of the train cars in any station, as well as a more simple maintenance work during a train breakdown. Unlike traditional electric trains, the engines of high-speed trains are distributed on each bogie differently. Also, they have different types of bogies called Jacob's bogies. Jacob's bogies are not to be found underneath a piece of rolling stock, but they are placed between 2 car body sections. The weight of each car is spread between the Jacob's bogie. This arrangement provides the smooth ride of bogie carriages without the additional weight and drag. Despite their safety features, lower weight and simpler and cheaper construction, with Jacob bogies, the vehicles are semi-permanently coupled, so they can only be separated in the workshop. 10 years in the industrial supply sector have led JAES to become a qualified partner for some of the most important railway companies, providing its technical support over a wide range of industrial components necessary during the production process of these incredible machines. Indian Railways is exploring the possibility of a superspeed, also called ultra-high-speed, rail network in India. The future standard is represented by high-speed trains, which will be always powered with a 25 kilovolts AC railway electrification system. These types of trains will be way more efficient than the actual electric trains. After this long journey, the JAES CEO finally arrives in the beautiful city of New Delhi, which over the last few years becomes a dynamic mashup of past and future, and a crossroads of tradition and innovation. Finally, if you found this video useful, let us know by leaving a comment and subscribing to our YouTube channel to stay tuned on the latest release of new videos. Thanks for watching.